Perfect. Does anyone want to kick us off today?
I can go first. Sure. I'll volunteer.
Excellent. Thanks, Joe.
Let's see. This last week, I'm not sure if anything is, I don't think anything has changed on the EM front for MT from what I've been working on with there. I was able to get GeoAnna up on Conda Forge for the newest version of that. It should, it should be built with the compiled parts already inside of it on Conda Forge. It required a little bit of a small little hack to get it working on Windows through Conda Forge, but it should be okay. So, but if any of you guys are running into issues with GeoAnna on Conda Forge, let me know. It'll be fixed in the next release of it, but if not, installing it through PyPy will work because it'll just not install the compiled parts. It'll work just fine. I started over the weekend. I was a little bit bored, and I started working on my translating some old anisotropic layered resistivity code into GeoAnna. So it was a nice solution, a nice compact solution that handles full tensor anisotropy in a layered earth for electrical resistivity. It actually looks, it's a really interesting, it's a neat solution. And if you guys are in, what happens is that it's essentially not sensitive to any of the like XZ or YZ components. And it's only sensitive to anisotropy in a horizontal direction. And what happens is the XZ and YZ components essentially get projected onto the layers. It's a really interesting thing that happens, and it's complete. You can completely see it in the physics, but it's just a neat little thing that pops out. What else? Oh yeah, and then I spent the rest of my time working on a poster trying to get ready for AGU with the GWB posters. If you guys are working on it, we should have time to adjust them still up until the date that they need to be given. So if you have any AGU poster.
Excellent. Would you mind dropping the link in the notes for folks to check out?
Yeah, sure.
Thanks, Joe. Any other? Those are the things?
I think so. If anything else pops up, I'll toss back in my mind.
Sounds good. Thibaut, you're typing. Would you like to go next?
Okay, sure. So I spent some time last week, like continuing those 3 PR that I have, like the two small ones, the one for implementing the new eigenvalue estimation is ready to go, and ready to, well, I mean by ready to be reviewed, like, and all the tests are passing. And the same for the Wolf curvature condition, that it is now an option in your line search criteria. And same for that, I wrote the test, and all the tests are passing. So like all those 2 pairs are like, yeah, like ready to be reviewed. And for the PGI one, I've actually, like, I'm done in terms of like the implementation and moving things around to make things all neat and clear. And I've actually wrote also most of the documentation, but the building of the documentation still fails. But that's pretty much it. So I think that would be, we could start again the review process on that big PGI PR too. So that's kind of the 3 of the state of those three PRs.
Excellent. Thanks, Thibaut. I see Joe added a note.
Yeah, I was like, oh yeah, there's something else I needed to say. So the new SimPEG version got released. It's just a minor patch release at this point with some of those released pull requests that came in recently. It is also now just, I got it to move away from the Travis testing. It's now on Azure DevOps pipelines. if you pull your stuff into master, or pull the changes in from master into your recent branches, it should enable them to be tested on there when you do a pull request. If you'd like to test it locally, you can set up your own account on like the Azure DevOps. And if you'd like to test it like on your own forked branch, you can set it up just through there the same way. Yeah, that was the other thing.
Thanks, Joe. Mike, would you like to go next?
Yeah, sure. I'm trying to get the meeting started on my normal computer because my government computer is deciding that it's going to restart here in 10 minutes. So I guess I've just been kind of hanging out and working on trying to create some octree meshes for kind of the area we're going to be studying up around Clear Lake, getting some like topography and just working on getting a nice mesh designed for some of that stuff. Yeah, that's mostly what I've been doing recently.
Excellent. Soggy.
I don't have a really particular update. Yeah, I'm working with them like in these days, revisiting the quest data. So I haven't made a big progress, but we're interested in the IP effect in that region. And potentially, we could compare with the geochemical data and see if that could be useful. Anyway, that's where I'm at.
Cool.
Oh, I gave a talk in Colorado, and yeah, so it was nice to kind of see people who are using SimPEG, and also, yeah, it was kind of there are a few other people using SimPEG on that university. So it was yeah, it was anyway great experience.
It was a good talk. Jaja, would you like to go next?
Yes, sure. Yeah. Let's see. So not so much on coding part. I have a student, Kenneth. Kenneth is working on joint inversion. Well, he also used SimPEG, the joint inversion of airborne gravity gradiometry and MAG. Actually, the gravity gradiometry data is from the Falcon system. I think we use some of DOM's code, or yeah, I think we use DOM's code or T-Bot's code, right, for the gravity gradiometry, the GUV and components. Anyways, so he will defend in 2 weeks, and he got some very interesting results. So this is the airborne gravity joint inversion for niobium exploration. So we're using some data from USGS. I think the data were collected at Elk Creek. So once he defends, and we also want to show this, contribute this application example to SimPEG, just as a way to showcase the value of the joint inversion, because I don't think joint inversion has been accepted by the community as a value-added thing. Partly because we don't have many convincing examples, but this one, I'm still trying to understand the geology here, but we do get some results that are very interesting. Anyways, that's one thing. Another thing is that, towards the end of this semester, I'm packed with many non-research related things, but starting next month, I'm hoping to start coding in SimPEG, because I started one project last year in MATLAB. I already prototype all the coding in MATLAB. It's working fine, but I want to redo everything in SimPEG, because when I publish my results, I also want to publish the codes with SimPEG. So that's something that I'm planning to do next month. So hopefully, Lindsay, I probably will contact you if I have issues with. So this will be my first, real coding exercise using SimPEG. Looking forward to that. Yeah, thank you. That's all from me.
Excellent. Will Kenneth's defense be open? Like, would we be able to join?
I think it'll be around December 11th. Yeah, it will be open. Yeah, anyone can join. I will send you the link. Yeah.
Excellent. Xiaolong, would you like to go next?
Yes. So last week I didn't do too much work. So I just start learning the Monte Carlo method and the Hamiltonian Monte Carlo for the inversions. And also it's just at the beginning part, beginning state. And this is also my second project. So I'm thinking in the future, I'd like to implement the Monte Carlo or Hamiltonian Monte Carlo inversions with the SimPEG. I will definitely use at least a forward part from the SimPEG. Yeah, that's all.
So Xiaolong, can you elaborate a little bit? You said multicolor. I'm not sure what technique you were talking about.
Monte Carlo.
Oh, Monte Carlo. Okay.
Monte Carlo.
Thank you. Sorry, my bad.
My bad.
That sounds pretty cool though, multicolor.
Yeah.
Yeah, the Monte Carlo method in some ways very similar to the geometry contact inversion that Peter Lillywand and Colin Ferguson they recently published. You have nodes, right? You're trying to figure out where the nodes are. Anyway, Xiaolong, do you want to update us on the cross gradient checks, the tests?
Yes. Yeah, I finished test the Jacobi and the Heisen matrix of the cross gradient, and I also created two simple blocks and calculate the gradient of these two blocks. I will check with Dr. Swenz early next week to make sure everything is right.
So you're not ready for a full review, Xiaolong? You're still working on that cross gradient? Because I know you've asked for, you put it as a pull request, right? But I don't think no one looked at it yet. Are you ready for a review, basically?
Yeah, I'm ready for the review.
That sounds good. We might, if folks want to take a look, because I think there's a fair bit of overlap with Thibaut's work as well. So it might sort of take a little bit. We might need to do a couple passes at both of those things. Joe, I don't know if you have other.
Yeah, I've had a thought about that, and I think we should probably merge one branch into the other first. At least so Thibaut, now that once you have all your PGI stuff at a decent point, I think it'd be easier to merge it into there and then merge it in together at some point. Just so we can work on it a little bit first before it gets merged into master. At least that'd be my thought about how to go about that. Yeah, just because I know there'll be some changes, so we'll have to deal with merge conflicts as well. So it might be easier to do it that way.
Yeah, there might be one thing I can think of right now is that one thing we discussed and we did on my branch right now is that we started to divide directives into like different files, like there is like kind of like regularization where you have like directives that are specific to PGI, for example, are in their own directive file and under directive folders. So maybe that's an organization we can do also as part of the cross gradient to facilitate the merge of directives there. Because I think you already, for regularization, you already have that separate file where you put the cross gradient. So that's good. But that may be one easy merge conflict that could be fixed prior to that. Is that? You don't seem sure, Joe.
Oh, I'm still just thinking if what I even suggested is still the best way. Open to suggestions. Like I'm just,
That's fair. Well, we can maybe start to take a look and then even just like come up with a bit of a game plan and chat about
that. We can still like keep contributing and iterating on it as it is right now. So we can improve it already. Like we can already do some improvements on it or changes that would be necessary. Yeah, these two branches are definitely gonna have to be resolved with each other before they get merged into master.
Yeah. Thanks. Dom.
I've continued my work. Probably put about like 8 hours on the tiling stuff. What I've tried to do, and so far so good, is to parallelize the tile creation also, right? Because right now we're hitting a bottleneck where if you increase the number of tiles, the whole process took longer because everything was done sequentially. So now, basically be able to launch all the meshing and all the tiling creation in parallel. And then after this, fire up the sensitivities all in parallel, and then launch all the, then the inversion is all parallel. So it's looking pretty good. Encountered some issues with properties. I personally would kind of like to be able to just use getters and setters instead of the properties package, because there's just a lot of stuff happening under the hood that we don't have full control on. Things are being called on before initializations. And anyway, and then the other big thing is that the latest release of SimPEG, or I should say discretize, Dieter, you flagged it too, right? It's throwing a ton of warnings. So that's two things. It forces me to update all my all the other packages that depend on SimPEG to update them all. But at the same time, it's kind of like it was my pain of this week. Is there probably more for Joe? Is there any way to be able to know where the warnings comes from? Because it's a bit annoying, right? You get a warning like change this and discretize, but you don't know where it's called. So then you need to like search through your library. It's like, okay, where am I calling it, right?
Yeah, I mean, you can make it like error on warning if you want to.
On my side, or it has to be on the discretized side?
Like on your side, you can make it like throw an error on warning, and that'll like cause a traceback.
Okay, and that's on that's in where would I do that? It's like a global command, global Python command.
Yeah, I think so. I'd have to look it up again. I know you can do
I'll look it up.
I think it's import warning and then warning hyphen error, and then you choose the package and the warning. You can, it's fine grained. So it can raise only error on some warnings, for instance. So you can,
Okay, that's perfect. Yeah, that's all I need, because otherwise it takes forever to find.
Okay, so the only thing that like should have made it not actually run is if like I've said before, if the those like shape type properties like BNC and then like the vector NN things, if they were treated as NumPy arrays before, well, now they're just tuples, they're immutable tuples. So that would have been the only thing that actually like broke.
Yeah, no, it's just lots of warnings, and sometimes those warnings are hit like multiple times, right? It just doesn't do it only once; it just keeps doing it. Yeah, that's okay.
I've got a change ready to go to switch them off for deprecation warnings, at least for now.
That's good. That's it for me.
Thanks, Tom. With the parallel side of things, have you sort of settled on what you think kind of the best ways to be interfacing to Dask is because we were using delayed before, but now that's not the case. It's now like the futures in the client. Is that?
It's just a way to trigger the computation, right? Because everything under the hood is a delayed function. It's just now we're going more towards the Dask.distributed, and that allows you to. That's amazing, right? So it allows you to basically launch delayed functions without stalling the kernel. So you can just tell your client, fire up this computation, and then the script or whatever your code is going to keep running, right? And then the thing's going to be running in the background, and then eventually you might need this vector or this computation, and then only at that point then you wait for the result to come back. So that means that we can fire off like tiling to bunch of workers, like do this, do this, do this, do this, and then only at the end you just wait and then you collect the result from all your workers. And so it's much more efficient, and then we can do like the super parallel, like distributed memory approach.
So do you mean it like starts running things before the graph is fully fleshed out?
No, so the client will tell a worker, and a worker is like, let's say, a node on your cluster, right? It's gonna say, this is your job. It's gonna build a graph, and I'm not sure if the worker builds the graph. I think the client builds the graph and just gives it to the worker.
I think it's the client, yeah.
The client does, yeah. So the client is kind of like the master of ceremony, right? That knows all the workers and all the threads and all that stuff. So it will build a graph and it will send it out. So there's overhead, right? Every time you send a job, there's like a few milliseconds to exactly that, build a graph and like schedule it. And then once that's far up, then you can keep going, right? You can keep computing. Yeah, it's really neat.
I'm just curious.
There's a few. Sorry.
I'm just curious, like what makes it different than a normal like dask delayed, like.
Because the dask delay, if you do compute, it's just going to stall your everything, and it's going to wait for the calculation to be done, right? So it's asynchronous versus synchronous calculations. One can be done.
Is it basically just like you're asking for the result later?
Exactly, and that's the future. That's the notion of future. So when you send a job, the worker is going to send you back a future, which is basically just a pointer to an operation that's currently going on, right? And so you can keep going on with the rest of your algorithm.
So you're essentially just building a bigger graph.
No, the graphs stay small. That's the beauty. Yeah, we want short graphs. We don't want a super wide graph, because then it gets bottled down into like a lot of computation. So you want short graphs, but send in sequence. That's kind of like the best way to do that so far. Yeah. For instance, JVec is going to be one process sent, and then it's going to return a future, and then you're going to be giving a future to the JTVec, and then now the next worker is going to grab the future and the next operation, and when it's ready, it's going to fire it up. Yeah. I'll give you a demo once it's ready.
Okay, excellent. John, you were about to say something?
I definitely second everything that Dom's saying. Yeah, distributed. Yeah, dask distributed and everything. Make way better performance.
Yeah. You have to be careful, right? You have to have more details about the future and how you're handling it. But it's good. It's fun stuff.
Excellent. I look forward to seeing a demo whenever that works. John, would you like to go next?
Yeah, it's a little short this week, other than running those models for the AGU there. No worries. I've been pretty busy on the work side of things. I did start getting back into the tiling just maybe a couple hours. I might have to talk to you, Dom. When you're like, that's what I was doing, was launching so you can do the tiling in parallel. Did you generalize that function, or is that just for your potential fields and stuff right now?
No, so it will be you just send XYZ locations and a base mesh. So I kind of reverted the way around, right? Before we were creating all the tiles, and then creating the global mesh. It's actually better if we create a global mesh first, and then just send locations and say, give me a mesh and a simulation with it. I think it's better. It's better that way.
Okay, yeah, that's kind of like I was just doing it so they would send all the simulations with the meshes as well. But if yours is generalized, I'll just kind of maybe put mine on hold then, or virtual we got kind of thing, and see what's going on.
I pushed it, so you should be able to, or if I haven't, I will do it now, and then you'll be able to see it.
Yeah, I haven't looked yet this morning, so I'll look. And then I guess maybe start picking away more at the pull request for the MT. I guess it looks like some of the tests aren't passing, so I should probably take a look at that. I guess I've started the Dask stuff, bringing that over. The GetJ Dask I haven't finished yet, but I'll pick away at that stuff for sure.
Thanks, John.
That'll take a little bit of adjusting. I have an idea of how to get those receiver functions, like to get RX deriv to work without providing a V.
Oh, is that going on in the test?
I don't know about the test, but as far as the get J function.
Oh, the get J. Oh, sorry. I see. Yeah.
I can help you with that when you get to it.
Excellent. Dear.
Yes, same as most. I was mostly busy with the HU and currently with some manuscript revision and students. So coding, absolutely nothing, except the same as Tom said, yeah, these errors that you can switch off. I have the deadline next Wednesday of my paper. And then I gonna adjust the EMG3D for discretize, and then it's over. I just can't do now. That's why I asked in the chat. But yeah, it's just one more week.
Have you had any other like kind of issues besides what you've been working on as far as migrating it to the new version?
No, it was really just this shape tuple VNC, and all the rest works fine. But because I use HX and well, I use almost all so much within EMG3D that yeah, it really accumulates. And what I did find out when I then send off with the futures package, so I have 10 kernels and send off 10 jobs. Each jobs reports back each error. So you have a massive wall of red.
It's interesting. I got it hooked up so that the Azure pipelines will show every like a little note about like every single test that's failing, passing, and the number of warnings thrown. So like SimPEG, it shows that there's like X number of thousands of tests. On discretize, there's thousands of tests, and they're all passed through. But then there's like 12,000 plus errors, or not errors, but warnings that it's thrown. So like, I purposely did that on discretize so I can make sure that the backporting stuff worked properly. So the next pass will be just to update the tests to not do that.
Yeah.
Hey, we haven't updated the regularization mesh with the latest discretized, right? I was looking at it and it's still using the dot vol instead of cell values. And we should probably
the only thing I did with SimPEG with this major or in this next patch release or this most recent patch release was to switch everywhere that it assumed that the VNC and like those other type properties were NumPy arrays. So now it does not assume they are NumPy arrays, and therefore it will work with an older installed version of discretize as well as the newer one. That was the purpose of this, to make sure that the current SimPEG worked with the previous and upcoming. So if I switch the vols to cell volumes, it would obviously break it if you had an older version of discretize installed.
Makes sense.
Excellent.
But so I wasn't sure, do you plan to go back to deprecations warning or not?
Yeah, for discretize, yes. So we'll go back to a deprecation warning.
For like one minor release or so. Yeah, okay, cool.
Excellent, thanks, Dieter. Doug.
Nothing much here. I think there was a few days that were totally consumed with AGU. It would be so much nicer just to give a live talk where you're actually standing in front of the audience and perhaps even see a big timer underneath to know where you are. But anyway, all that's done, so we're on to other things.
Lindsay, did you show him your little speed trick?
Yes, but he didn't end up needing it. I definitely did, and it sounded like a chipmunk, but whatever. It's done.
But that definitely works. Like if you just have like 30 seconds or maybe a minute to chop out of 15, it speeds it up. It's when you know the person, you instantly recognize, oh, wait a minute, there's something wrong here. But then after about 45 seconds, your brain just sort of tunes in, and then you don't notice it anymore. So I was impressed.
Yeah, it was really interesting. Like I told Lindsay when she showed us when I watched that one, like it didn't sound your voice didn't sound different. It was just like your cadence, like the rate, like you have your normal cadence is definitely a little bit slower than video. So it was kind of interesting that I could like take that out and see it.
You could even be more aggressive and put on your title slide, speed back half, please slow down.
Peter, that's brilliant. That's brilliant. Yeah, you put a half-hour talk in, speed it up by 2. I love it.
Well, in iMovie, you actually, so I used iMovie to do that, and you do have to select that you want it to preserve the pitch. Otherwise, it does actually compress your audio, which changes the frequency. And so then you sound completely different, which was really weird when I first sped that up. I almost like threw the video out, but all was recovered. Cool. So I guess, yeah, my updates are I gave an AGU talk. Huge thanks to John and Joe for pushing really hard on the MT code to pull that together. I'm really excited about what we were able to show is a comparison between the SimPEG inversion result for the L block and the UVC inversion result that Devin had put together. They're quite comparable, and even sort of iteration times, I was really pleased to see that we ran that in series. So we ran 3 frequencies, and it was, I think, it was 42 minutes. John, just jump in, correct me if I'm wrong. I think.
Yeah. Well, 42 minutes for an iteration, yeah. Or so, yeah. That's right.
Yeah, and I think what the UVC was like 16 or 17, something like that, or 14.
With all 3, yeah.
Yeah. So basically, if we are successful in parallelizing and dividing by 3, we should be pretty comparable in terms of timing, which was really encouraging. So quite excited about that. Yeah, so feel free to check that out. And then if you have comments on the slides or anything like that, we can always, we'll hopefully be giving some future updates on the MT side of things, so we can always improve. Other things. So I guess also wanted to maybe flag the governance discussion and see if folks would have time potentially later this week or maybe next. If you're interested in sort of joining in on that conversation, would that sound reasonable? I'll send around a poll, but have people who wanted to take a look, have you had time to take a look? I see some nodding heads. Ish. Okay. Perfect. Thanks for the thumbs up, Thibaut. Sure. Okay. Well, I'll send out a poll that like spans the end of this week all through next, and we can find a time slot and sort of kick off that conversation. Other things. I think that's basically the things I've done. I see Devin's jumped in. Devin, do you have any updates you'd like to share?
Yeah, sure. I'll keep it pretty short. I've sort of been grinding away on the theory sections for discretize. So, we came up with a way of presenting this type of information on EM GeoSci. So I'm following that structure, and it's organized in the same order as the tutorials. So it would really allow you to go through the theory and then link to the tutorials and do things in parallel if you wanted to. So I'd say I'm like 70% of the way through it. And then Doug has agreed to review the material once I've made my first draft, and then we can make some decisions on if we're happy with the convention for variables and vectors and that kind of stuff. So progress is being made. I want to get it done within a week and then get a review. That's about it.
Excellent. Thanks, Dev.
Yeah, I was looking over, I read through a few of those things already. It's looking like it's on a good track.
Excellent. Cool. Does anyone else have other discussion items and or suggestions for anything you want to discuss in more detail next week?
I had a suggestion even after next week. It's been a while since we've done a kind of SimPEG coding party. Are people open to maybe one again? So maybe Friday afternoon? or if not, if we don't get enough people, maybe we can do next Friday or something. But it's been a while. It'd be nice to do something like that with everyone again. People are open to that Friday or so. Just kind of Friday afternoon, we'll host a Zoom meeting, pop by, go through some old bugs, pull requests, catch up, have a good time. No
Well,
pressure.
our American friends might be eating turkey.
That should be Thursday, right?
Thursday, yeah.
Bring some turkey leftovers then.
That look like the coding party. No beers, right? No turkey. So what does it look like? What do you do?
Yeah, it's a dry party. We just look at each other sober. It's great. The best party you ever been to.
I mean, if you want to have a drink, that's on you. I'm not going to tell you what you can and can't do.
Okay.
It's not going to. They're not.
I drink beer.
I'll have a beer too. Yeah.
But it's mostly we end up, like I said, we go through some old pull requests. People are working on their own projects that they have. It's a nice way to just kind of have people to talk to while we're working on bugs, and people bring up questions like, "Oh, what's this thing? What was this? What were you thinking in this bug? Like, what were your thoughts here?" It's just kind of a
okay. Yeah, I'll be very
kind of thing. It'll be about probably what times we've been doing, like 3 o'clock, 4 o'clock Friday. We've been doing it at 3 o'clock. I don't remember.
I think if we can do it at 3 or 3:30, that'd be great.
Okay, let's plan for around then. Just stop in whenever you like.
That sounds good. Excellent. Okay. And then Dom, can we maybe put you on the hook for a demo next week, or do you think you need a bit more time?
A demo, yeah, demo definitely. Yeah, I can do that.
That would be excellent. Yeah, I'm really excited to see what you've worked through.
It'll force me to just learn.
Excellent. Cool. Okay. Does anyone else have other things?
Lucy, a quick question. So the MT thing you were talking about, is it in 1D, 2D, or 3D?
All of the above. No, so we've got 1D in place, been working on a 2D, but that's not done yet. But the inversion that John ran was in 3D on the Octree mesh.
On the Octree mesh, using SimPEG or?
Yeah.
Okay. So since SimPEG does have the functionality of inverting 3D MT already? Yep. Okay. Yeah.
It's all done in serial. Like we were saying, as soon as we can do all the frequencies in parallel, it should be on par with the UBC speed.
Okay, that would be awesome, because I do have a data set from US Array, the US Array, the MT part, right? MT part, and also graphed data from Yellowstone. So people have done some joint inversion work there, but I haven't been able to do that because I don't have a Python code for MT. I do have the MT code from Oregon State, but it's in a completely different system. So it's nice to know that SimPEG already have that function. Okay, cool. Yeah, thank you.
Yeah, so it's still
in that regard, have you used the mutual information regularization?
No, I have never used that. I tried about 10 years ago when I started my PhD, but realized that mutual information has a lot of local minimum, so I didn't go down that path. No, I never tried that. In the context optimizer, I did spend some time understanding it and coding up given two images and try calculates the mutual information. It does help. It is a measure of the structure similarity for sure, but it's just that when it comes to optimization, there are many problems back then. So now I don't know how Max. So Max presented a EM webinar last week. He used the mutual information and showed some good results. I don't know how he managed the numerical problems. Yeah, I don't have any personal experience of running joint inversion using mutual information.
Because that was actually a very nice result that he got out of that.
Yeah, but that is a very good result. Although I would say probably most of the density features in the deeper depth are probably dominated by information from the seismic part, right? So it will require some caution to interpret the deeper density features, because most of them are I mean, gravity are not going to have that much resolution for you to be able to resolve these detailed structures. But he does show some anti-correlation between the features. That is something really worth looking into.
Yeah, that was a really interesting talk. I also tuned into Karen's this morning on marine geophysics, and there were some interesting examples. So if folks are interested in that, so they showed some stuff with respect to like mineral exploration, but also with pipeline monitoring, which is quite interesting. Is electric fields, or they're looking primary. Well, they collect both electric and magnetic field data to as they go along these pipelines to check the anodes, like the sacrificial anodes, where they're at, but then also try to detect corrosion and anything like that along the pipeline. So it's kind of a cool talk.
Sorry, who gave the talk? It was Karen
Whitemeyer.
Oh, okay.
Yeah, with ocean floor geophysics.
Oh yes, she used to work on the gas habits, right?
Mm-hmm. Yeah.
Yeah. Okay.
Ocean floor geophysics. It's really interesting. If you look on their website, they made a deal with PGS to use their streamer EM system. And shortly after, they made a deal with EMGS, who also shut down, to use their node-based EM system. So they have now access to both of the most used marine CSEM systems. So it's a place to watch. It could be interesting what they're going to do with that. And it's Canadian, so it should be it's in your backyard. So.
Yeah. Excellent. Cool. Any last items?
Yeah, maybe one. I was kind of hoping Sagi would be here for this, but EM1D, we've done a lot of stuff on it. Just hoping that we can kind of push it across the finish line in the near future.
Yes, now that the GeoAnna change has been pushed, we can change that and switch it over to using that kernel, and it should be good.
Cool.
Excellent. Cool. Okay. Well, thanks everyone. And Joe, will you circulate a link for Friday? Is that all right?
Will do.
Excellent. Thanks.
And that'll be this Friday or next Friday?
This Friday.
Okay. Cool.
Perfect. Thanks everyone. Have a good afternoon. Happy Thanksgiving to folks south of the border.
Bye everyone.
Bye. Take care.
Bye. Yeah.